Alright, this video is going to be over evaluating, right, sine, cosine, and tangent in the coordinate plane for any angle. And if you are looking to figure out how to find like the sine of, say, 312 degrees, that's not what this video is going to be about. All of the angles that I use in this video will relate back to the first quadrant of the unit circle, and as you'll see in this video, will relate back to the special triangles. So without further ado, here are a couple things you'll need for this video. You'll need to understand how to label a 30, 60, 90 triangle and a 45, 45, 90 triangle. So this is 45. Call this 30. That's 60. And so then this is 1, 1, square root of 2. And then this guy across from the 30 is 1. Then square root of 3. Sorry, it's a little smushed. And then the hypotenuse is 2. Alright? But we'll need those as time goes on. Okay, so let's start. Number 1. Let's say that you are trying to figure out the sine of 570 degrees. Okay, that's what's being asked of us. First thing you are going to do is you are going to draw this thing in the coordinate plane so that we can figure out what quadrant it is in. And so here we go. There's my initial side. 360 degrees is all the way around. 360 plus 180 is 540. So it's going to keep going around half. And then there's about 30 degrees more that's left. And so my terminal side is in the third quadrant. So if you were asking yourself, what quadrant am I in? I'm in quadrant 3. Why is that important? Because in quadrant 3, the sine is negative. So I know that the sine of 570 degrees is going to be a negative number because of the quadrant I am in. Remember, in your trig class, you've learned that the y-axis, this thing I'm highlighting in blue right there, is related to the sine, and where the y values are negative, so is the sine. And so the sine of 570 degrees is going to be negative. Next, you need to find the reference angle, okay? The reference angle is right here between the closest x-axis and the terminal side. We call it theta prime. And if you can figure out the reference angle, you will be able to figure out the sine of 570 degrees. So what is this space in between there? Well, we went 570 degrees to the terminal side, and I know that to go back to this would have been 540. So this space here is 30 degrees more. So theta prime is 30 degrees. The beauty of the reference angle is that if you can figure out the sine of the reference angle, 30 degrees, it will be the same as 570, except the fact that it's going to be negative. So now I'm going to come over here to my 30, 60, 90 triangle, and I'm going to do the sine of 30 degrees. Here's 30. Opposite is 1 over the hypotenuse, which is 2. So the sine of 30 is 1/2. Therefore, the sine of 570 degrees is negative 1/2. And that's it. You could do the same for cosine, right? It would have been the same reference angle. So cosine of 570 degrees. Okay, and the reference angle would have been 30. And as long as we figure out what the cosine of 30 is, which would be adjacent over hypotenuse, and so that is root 3 over 2. Root 3 over 2, and since the cosine is negative in the third quadrant also, because it relates to the x values, I'm highlighting it here on that coordinate plane, and so then this would be negative square root of 3 over 2. And that's how you would evaluate the sine of 570 degrees. All right, let's do one in radians because everybody loves radians. So let's pick one out. Let's go with, let's go with the tangent, okay, of 4 pi, let's go negative 4 pi over 3, okay? The tangent of negative 4 pi over 3. So first thing you're going to do is you're going to draw the angle as well. Here's my initial side right there. And then negative means we go clockwise, and all the way around halfway is pi, so that's 1 pi, and then I need to go another third, so that'd be 4 pi over 3. Negative 4 pi over 3 would be right there. Next step, remember you're going to find the reference angle, so right here, theta prime, and you want to get that in radians if you can, right? And in radians, theta prime can be found in this problem by doing 4 pi over 3, which is our angle, minus pi, and so 4/3 minus 1 is 1/3, so it's just pi over 3. Your reference angle will always be positive, right? So we're trying to do the tangent, and so we want to look for the tangent of pi over 3. It's good to remember what that is in degrees so you know which triangle you're looking at. Pi over 3 is 30, 60, 90 triangle. Sorry, class just got out. It's a 30, 60, 90 triangle. And pi over 3 relates to the 60-degree angle. And so 1 square root of 3 and 2. And now you've got to do the tangent of 60 degrees. Opposite over adjacent. So root 3 over 1. So just the square root of 3. Next thing you got to do is decide if it's going to be a positive answer or a negative answer because you ended up in the second quadrant. And so in the second quadrant, the x values are negative and the y values are positive, which would make the tangent negative. And so therefore the tangent of negative 4 pi over 3 is negative square root of 3. And that's it. Have a great day.